remember to dye the eggs?
Oh no, I forgot.
Oh no, we have to do it quick.
All right, let's go.
I wonder how this works.
You know what? I think we could find out. So this is going to be the chemical equation of the process of dyeing eggs. It starts with the two reactants, calcium carbonate, representing the eggshell, and acidic acid, which represents the vinegar. These two reactants are going to produce three products. The first one's going to be calcium acetate, the second H2O or water, and the third is carbon dioxide. So for today, we're going to be determining how many grams of vinegar are needed when we have 2.2 grams of calcium carbonate present. To do this, we're going to need to use stoichiometry, a grams to gram conversion. So to find this out, we need to do a grams to gram conversion. We're going to start with our given 2.2 grams of calcium carbonate, and we need to convert that to moles of calcium carbonate by doing the grams per mole conversion, with the molar mass being 100.09 grams per mole. Next, we need to use the mole ratio of calcium carbonate and vinegar, which is a 2-to-1 ratio. We're going to put the vinegar in the numerator because that's the conversion that we want. Then, after we do that, we're going to use the grams per mole conversion for vinegar, putting the grams in the numerator spot. Once you multiply and divide your way through this problem, your answer should come out to be 2.6 grams of vinegar. All right, now we're going to try to be determining both the limiting and the excess reactants for this problem. Our given is going to be 2.2 grams of calcium carbonate and 5 grams of vinegar. So to solve this problem, we're going to choose the product of calcium acetate to determine which reactant is limiting and which one is excess. To start this off, you're going to start with the given calcium carbonate, 2.2 grams. And because it's in grams, we need to convert it to moles. So you're going to put 1 mole of calcium carbonate on top and then the molar mass on the bottom, which is 100.09 grams per mole. Then we're going to use a mole ratio between calcium carbonate and calcium acetate, which is a 1-to-1 ratio. Our answer will come out to be 0.0219 ... but we need to remember sig figs. So our answer should be 0.022 moles of calcium acetate. All right, for the next one, vinegar, we're going to start with the given 5 grams of vinegar. And we need to convert this to moles because it's currently in grams. So we're going to put 1 mole of vinegar in the numerator, and then we're going to put its molar mass in the denominator because we want to get rid of grams, which the molar mass is 60.05 grams per mole. Then we'll use the mole ratio between vinegar and calcium acetate, which is a 2-to-1 ratio. Since we don't want vinegar anymore, we're going to put the 2 moles of vinegar in the denominator and the 1 mole of calcium acetate in the numerator. Our answer should be 0.0416 ... but we need to remember sig figs, so there should be 1 sig fig. So our answer really is 0.04 moles of calcium acetate. Because calcium carbonate produced less moles, it's going to be the limiting reactant, which leaves the leftover vinegar is going to be the excess reactant. All right, now we're going to do a percent yield equation. So you created 18.2 grams of a product. However, the instructions called for 19 grams. So what's going to be your percent yield? 18.2 grams is going to be our actual yield, which is going to go in the numerator, and 19 grams is going to be the theoretical yield, which is going to take the place in the denominator. We're going to times this by 100% to calculate percent, and then from that we should get 95.8%.
Wow, who knew all these chemical reactions were happening while I was dyeing my eggs for Easter?